Today we will learn the hydrolysis of weak acid, salt of weak acid and salt of weak acid and strong base. Okay. Therefore, we know that one of the weak acids CH3COH and strong base, if suppose NaOH is strong base, therefore salt you obtain from this is the CH3CONa. This salt is called as the salt of weak acid and the strong base. It is made up by the combination of weak acid and the strong base. Okay. The salt, when dissolved in water, it gives CH3CO minus plus Na plus. Okay, and this is a conjugate base is obtained from acetic acid. Okay, for understanding purpose we have taken acetic acid and its conjugate base. Okay, we know it's obtained from the acetic acid, that is a conjugate base, and acetic acid is a weak acid, therefore conjugate base is obtained from weak acid will be strong conjugate base. Okay, therefore this conjugate base is strongly accept the H plus from or hydrogen from water and breaks the water. Okay, therefore hydrolysis of water takes place. CH3, it obtains CH3COOH plus OH minus. Like that, hydrolysis takes place. Okay. Then, by applying the law of equilibrium, we can obtain the hydrolysis constant for this base, okay, which is made up by weak acid and the strong base. Therefore, by applying equilibrium law, we can find out the hydrolysis constant, and hydrolysis constant is denoted by the KH. Okay, therefore KH is equal to the concentration of the ions upon the concentration of the salt. Therefore CH3COOH and concentration of H plus ions, okay, sorry, right hand side upon the concentration of the salt. Okay, this is a degree of hydrolysis constant. Now we have to find out the degree of ionization constant of the acid. Okay, particularly that acid which gives the strong conjugate base. Okay, that CH3COH gives the CH3CO minus strong base. Okay, therefore we will use the CH3COH, okay, from where our salt is made up. Okay, salt is made up by CH3COH and the NaOH. Okay, we will take the acetic acid because acetic acid gives the strong conjugate base. Okay, by using acetic acid we can find out ionization constant of that acid. Okay, therefore CH3COH is a weak acid. Okay, weak acid means it dissociates very less amount, therefore we have shown that equilibrium. Okay, CH3CO minus, it gives that particular ions. Then by applying law of equilibrium, then the Ka. Okay, A stand for the acid because we have the dissociate the acids and find by we have applying the equilibrium constant for the dissociation of these acids. Okay, therefore Ka will given as the concentration of right hand side, that is that ions, dissociated ions, upon the concentration of that particular acid. Okay, remaining acid. Now we will find, we have known that the degree ionic product of water is equal to Kw H plus ions and OH minus. Okay, already we have derived all these three equations. Okay, we have used a degree of ionization of acids and the ionic product, because this acid, the conjugate base is the breaks the water. Therefore, that conjugate base which breaks the water we have used here. Okay. Firstly, we have found out the hydrolysis constant. Okay, because the base will take the like that CH3CO minus. Okay, that is conjugate things. It gives the after hydrolysis CH3CO H plus OH minus. Okay, that equation we have written from this equilibrium. Okay, now we have to find out what is the relation between Kw, Ka and the Kh. Okay, already we have, if we take the Kw upon Ka, Kw we know that H plus and OH minus ions, and Ka is that is CH3CO minus and H plus ion and H plus ions. Okay, then to this is divided to this is the CH3COH, therefore it is multiplied CH3COH. Okay, therefore common ion, this is the H plus ion is we will remove or cancel to each other, and remaining term we have written here. Okay, therefore Kw upon Ka is equal to CH3COH OH minus and CH3CO minus. Okay, this is okay, sorry, for this case we have used the minus. Okay, therefore minus from this you obtain the hydrolysis. Therefore Kw upon Ka will be is equal to Kh. Okay, first relation we have found Kw upon Ka is equal to Kh. Okay, that is the relation we have, first relation we have found out. Now we have to find out the degree of hydrolysis. Okay, therefore from our salt, okay, from the salt you break the H2, you will obtain the salt CH3COOH plus NaOH. Okay, simply instead of this we have written NaOH or OH minus ions. Okay, we have to find out the degree of hydrolysis. Okay, degree of hydrolysis is denoted by the H. Therefore H is equal to number of salt hydrolyzed number of moles of salt hydrolyzed upon total number of salt. Okay, in this case at the initial the concentration of CH3CON is C. At the initial it dissociates 0,0. After the sometimes how many it gives the ions? Okay, then after some time there is the degree of hydrolysis. We have to find out number of salt hydrolyzed. Number how many salt is hydrolyzed. Therefore, how many salt hydrolysis means that how many CH3CO minus is obtained and the OH minus is obtained. How many CH3COH and the NaOH is obtained. That it means the number of salt hydrolyzed. Okay, in this case we have to add the time of equilibrium. The H is equal to number of, so we have to find out the number of salt hydrolyzed. Okay, if suppose we give the its upon the total number of salt, total number is the C. Okay, therefore number of salt hydrolyzed will be is equal to H into C. Therefore, after at the equilibrium, it is total number of hydrolyzed is H into C. Therefore, H into C is hydrolyzed. Therefore, from the initial, we have to remove H into C. Therefore, it remaining things. Okay, suppose it is 10 molecules at the start. Then after it dissociate 5. Then how many is remain? Then 10 minus 5. Okay, like that, C minus SC is the remaining salt which is not undergoes the hydrolysis. Therefore, total number of salt hydrolysis is the H into C and H into C, and that is C is the common. Therefore, C 1 minus H. Okay, total number of salt remaining is the C in bracket 1 minus H. Okay, therefore, by applying law of equilibrium. Okay, therefore CH3COO minus we use the for the hydrolysis. It hydrolyzes like that. Okay, CH3COOH and the OH minus. Okay, we have seen at the previously. Therefore, by applying, therefore, degree of the hydrolysis constant Kh will be given as the concentration of ionized ions upon the concentration of the salt. Therefore, H into C into H into C upon, okay, these two salts concentration, C 1 minus H. Therefore, CC 1C is cancelled. Therefore, H square into C. Okay. Now we have 1 minus H. KH is equal to, that is the hydrolysis constant is equal to H square upon C 1 minus H. Okay. We know that degree of hydrolysis, such process degree of hydrolysis, H is the very small. We will take the is equal to 0 because very small amount of water hydrolysis takes place. Not all the hydrolysis takes place. Very small amount in hydrolysis takes place. Within the 1 lakh molecule, 100 molecules hydrolyzed. It is a negligible thing. Okay, therefore H degree of hydrolysis is equal to, we have taken is equal to 0. Therefore 1 minus H, if you take the 0, is equal to 1. This quantity will be 1. Therefore H square upon C is the 1. Then H square we have to put at the one side and C will move to other side. Therefore KH upon C. Okay, this is multiplied. After move to this side, KH upon, it's divided by, okay, KH upon C. Therefore, we have obtained the H square is equal to KH upon C. H square is equal to KH upon C. Okay. Then we have obtained the KH is equal to KW upon K. Therefore, we can put H square is equal to KW upon KA into 1 upon C. Okay, we instead of KH we put the values KH is equal to KW upon K. Therefore, we have to obtain the H values. Okay, therefore we have to take the square root of H square. Square root of H square is equal to KH, H, and square of this quantity will be square root of KW upon KA into C. Okay, this is the degree of hydrolysis we have obtained. Okay, second relation we have obtained H is equal to KW upon KA into C, that is under root. H is equal to under root KW upon KA into C. Okay, now we have to find out what is the pH of that solution when we add that is our CH3CONA, that is salt of weak acid and the strong base. When you add in water, what will be its pH? Okay, therefore we know that the Kw is equal to H plus ions and OH minus ion. Okay, we know that minus log H plus ions is nothing but the pH. Okay, therefore we put the H plus ions at one side and make its minus log, and then we will obtain the values of pH, Kw upon OH minus. Okay, therefore we are interested in H plus ions. Okay, before going to the H plus ions, we have to put the values of, okay, OH minus concentration of previously was the CH3CO minus. When hydrolyze the water, you obtain the CH3COH and plus OH minus, that is at the concentration was the CH. Okay, concentration at equilibrium OH was the CH. Therefore H plus ions is equal to Kw, that is a C into H. Okay, therefore H plus ions is equal to Kw upon C into 1 upon H. We know that 1 upon H is nothing but the Kw upon Ka into C. Okay, it is this quantity H is divided, therefore we have to change all the our bracketed term Ka into C upon Kw. Okay, this denominator will be numerator and numerator will be the denominator. Therefore, because 1 upon H, this quantity we have taken the 1 upon H. Okay, therefore H plus ion concentration, we will move Kw inside the square root. Therefore inside, when we will give the square root, it should be the, okay, therefore Kw is nothing but the Kw square. Okay, like that Kw inside we will obtain the K square W into Ka into C upon C square. Okay, is gives C square is C is nothing but in bracket square root C square. C square into Kw. Okay, there 1 Kw and 1 Kw cancel and 1 C, and when C is counted, you will obtain 1 K square W, that is when Kw remain, K as it is, 1 C and the 1 C is the cancel, therefore C, Kw upon Ka upon C. Therefore, we have obtained H plus ions is equal to Kw into Ka upon C. Okay, square root of Kw Ka upon C. Okay, therefore H plus ions is equal to Kw Ka upon C. Okay, we are interested in find out the pH. pH is nothing but the minus log H plus ions. Therefore this term we have to convert it into minus log H plus ions. Therefore by taking negative log to the base 10 of both sides, left hand side also and the right hand side. The minus log H plus ions is equal to, okay, when we take the log of square rooted things, then minus log, it is connoted like that, minus log, like that Kw Ka upon C raised to 1/2. Okay, it is nothing but the, okay, x 1/2 is nothing but the raised to 1/2 is nothing but the x square root of x. Okay, like that relation we have used. When you log H plus ions is equal to minus log Kw, therefore minus log Ka, and if you take this like that, minus log 1 upon C. Okay, and when you take the 1/2 is the outside the bracket when we take the log. Okay, 1/2 minus log. Therefore minus log H plus is nothing but the pH is equal to 1/2 minus log Kw, we have known that minus log Kw is equal to pKw. Therefore, pKw minus log Ka is nothing but the pKa. Okay, the total term is the positive pKa. Okay, this can be, we can by like that we can use the minus 1 upon x log minus, then it can be connoted log x. Okay, positive minus, if it is minus, it is connoted log x. Okay, like that this will obtain the log C. Okay, pKw, we know that pKw value for the water is the 14. Therefore, by putting the 14, 1/2 into 14 plus 1/2 pKa plus 1/2 log C. Therefore, 7 plus 1/2 pKa plus 1/2 log C. Therefore, this is the plus, all are the plus. Therefore, the values of pH for this salt will be more than the 7, because 7 plus these values plus this value. Therefore, the pH for this salt will be more than 7. Like that way, we can find out the pH at 1/2 pKw plus pK plus log C. Okay, we have in this lecture we have studied the weak acid, salt of weak acid, and strong base. I hope you all get this very well. You understand this? Thank you very much.